Imagine it's Monday morning, users are complaining, the website is down, management want answers. The application team says it works on my machine. Networking team says it's not the network problem. So you do what many engineers would do. You jump into the terminal and run pingwebsite.com and it works. Interesting, right? The server is reachable, the network looks healthy. So why is the website still down? Today, we are going to solve that mystery. And by the end of this video, you will be able to understand what ping actually tests and also explain why ping can work while a website is completely unavailable. Use the right commands to identify whether the problem is the network or the application. Follow a simple troubleshooting process that works during real production incidents. And stay until the end because I am going to show you the command that I trust more than ping during outages. Also, if networking is an area you struggle with, comment networking below. I read every comment and it helps me decide which topics to cover next in this series. Let's begin. Now let's test ping. Ping space google.com. This looks healthy. Packets are going out, packets are coming back. Latency also looks very fine. But here's one important question. What exactly did we test? Did we test the website? No. Did we test the application? No. We just tested basic network reachability. That's a huge difference. Many engineers see successful ping message responses and immediately assume everything is healthy. That's where troubleshooting starts going wrong. Ping uses ICMP. What exactly is ICMP? It's Internet Control Message Protocol. Websites don't use ICMP. Website websites use TCP. And that's where the story gets interesting. Most websites use port 80 for HTTP and port 443 for HTTPS. Completely different protocol, completely different purpose. A successful ping does not guarantee a successful website. We are going to prove that today. Now let's start to build a real website. Let's create a real web application using Docker run. I'm using a web application here using Nginx port 8080:80. Press enter. This Nginx container will represent our production website. Now let's try to check by running this command docker ps filter name web application. If you look at the output here, this looks perfectly fine. This looks healthy. Website works. Users are also very happy. At this point, most engineers would stop investigating, but I am about to break one thing now. And I want you to predict in the comments what happens next. Now, let's check something very important. Applications listen on ports. The server might be alive, but if no application is listening on the expected port, users can't access the service. Here, we are using this command tulpn grep 8080, press enter, we can see something is actually listening because we ran nginx using this particular port 8080. That's a very good signal. The application is ready to accept connections. Application is running fine, port is listening successfully, website is also working. All three are connected. Remember this diagram, it's going to matter a lot in a few minutes. Now I am about to break the application. Before I do, I want you to make a prediction. Will ping still work? Don't skip ahead, take a guess. Comment yes or no before I run the next command. Let's see if you are right. Press enter. I did stop the application. Production outage. Users are complaining. Let's investigate now. Ping local host. Press enter. Ping still works. The machine is reachable, network is healthy, everything looks healthy. Or does it? This is where many engineers stop troubleshooting. And that's a very big mistake. Because we only checked one piece of the puzzle. Now, I will say curl localhost colon port 8080. Press enter. Now the website fails. This is exactly same scenarios you are going to see in production environments. The machine is alive, the website is dead. So what exactly changed? Let's try to gather evidence now. Once again, I'm going to run ss tulpn pipe grade 8080. Press enter. Now see the difference. Earlier, Nginx was listening. Now, nothing appears. No listening port, no application, no website. Very simple. As I said in the diagram, machine is alive, network is alive, but nobody is listening on this particular port 8080. Ping only proves machine exists. It never proved application exists. That's the key lesson of this entire video. And honestly, understanding this one concept will save you hours in production. Now, let's look at some real production examples. Ping works, website fails. This happens all the time. Applications crashed, containers stopped like we did in this video, wrong port configured, firewall blocked, reverse proxy issue, SSL problem, Kubernetes pod failing, all can produce the same exact symptom. Ping works, website fails. That's why experienced engineers don't stop at ping. They keep collecting the evidence until they solve the issue. Most engineers know ping command. Far fewer know the command I am about to show, and honestly, I find it more useful during incidents. NC Netcat command. This checks the actual service port, not the not just the machine. That's much more useful because users don't care whether the machine responds to ping. Users care whether the service responds. Here I see succeeded. Now I am going to run the same command to test if localhost port 8080 connection works. Press enter. I see an error saying connection refused. Nobody is listening. This is exactly what we expected because we stopped the container which was running. And that's the evidence we are looking for. Now, let's try to start the application once again and let's see the difference. I'm going to start the container, followed by I'm going to use netcat command localhost space 8080. Press enter. If you look now, I can see succeeded. Previously, it was failing because our web app was not running. Now we started it. Now the netcat shows the service is listening on this particular port and I can see the message succeeded. That's why I say this particular command is very handy during production incidents. I can easily figure out whether the port is listening or not. Imagine your application connects to PostgreSQL database. Would I start with ping? Probably not. I would test the actual database port. For example, Netcat database server 5432. Now I'm testing the actual service. That's much closer to how production troubleshooting works. This is the difference between guessing and troubleshooting. This is failing because I do not have any kind of service running, but I just wanted to show you an example. Let's try to understand the production troubleshooting framework. When something breaks, for example, website is down, don't panic. Also, don't restart random services. Do not guess blindly. Follow a process. First, DNS, then comes connectivity, then comes ports, application, logs, because evidence first, assumptions later. If you are finding this useful and you want more practical networking lessons like this, consider subscribing. Every episode in this series build on the previous one. And we are gradually moving towards real production networking incidents. A quick challenge. Let's test your understanding now. Imagine application stopped working. Ping works. Website fails. What's the first command you would run? Think about it. Let me know in the comments. My answer here would be ss-tulpn or netcat-vz depending on what I am exactly troubleshooting. Let's do a quick recap of what we learned today. Ping does not test websites. Ping does not test applications. Ping only tests the basic network connectivity. That's why ping always works. Websites doesn't. Is completely possible. And now you know exactly why. Have you ever faced this problem in production environment? Have you ever faced this problem in production? Let me know in the comments. And if this video helped you understand why ping works, website fails, comment networking. It helps me understand whether I should continue this series or not. And if you know another engineer who immediately assumes everything is healthy because ping works, share this video with them. In the next episode, we are going to tackle 3 errors every engineer eventually sees. First, connection refused. Second, timeout. And the third one is no route to host. They sound similar, they also look similar, but they mean completely different. One usually points to application, the second points to connectivity, and third points to routing. And once you understand the difference, the troubleshooting will be easier. Thank you for watching. I'll see you in the next video.